Okay, this deals with the law of sines. This is a homework problem from my math lab homework. This is the last problem in section 8.1. The reason why I made a video about this problem is because I got more than 3 people ask me on how to answer this question. And so I figured let's just make a little video and I'll post it online and you can look at the solution. I'm sure there's other ways of solving this involving other dimensions, but this is just kind of what I found out on my own. I kind of had a little bit of a hard time trying to come up with this, so hopefully this sheds a little bit of light into this problem. Okay, so what's the setup of the problem? We are given this little diagram, and right now I've filled out more information here. So what you are given is there's an angle alpha, there's an angle beta, you're given a length d, and then there's a length x, and the problem says that you gotta find the length x in terms of alpha, beta, and d by using the law of sines. I already sort of sketched out some things here, so let me just kind of walk you through what I kind of reasoned here. I tried to complete all of the triangles as much as possible first, just to kind of have more to work with. So remember, what was given to us was alpha, beta, d, that's given, and we need to find x. Everything else, who knows? Well, I know that this is a 90-degree angle right here. This is supposed to be 90 degrees. Okay, so let's just kind of keep on looking at the picture. Let me figure out some angles first. Well, if this angle is beta, then this one in red should be 180 minus beta. That's pretty much the first thing I started by thinking about. I'm like, okay, well, that's 180 minus beta. That's great. How am I going to use that? Well, I would like to complete as many angles as I can. I want to find all of the angles possible so that using the law of sines becomes a little bit easier, because the law of sines does require that you know some angles. So then I said, I'm looking at, right now there's this kind of obtuse triangle. So think about this triangle that has the angle 180 minus beta. So it has alpha as well. And so then I need to figure out the length of this little angle up here. So how do I find that angle? Well, I already know this too. I know alpha and I know 180 minus beta. So what I could do is add these two together, alpha plus 180 minus beta, and then subtract that from 180 to get this angle up here in black. And if you do that, if you say 180 degrees minus, and then I would open a parentheses, and then alpha plus 180 minus beta, you'll get beta minus alpha. I'll let you verify that. So that's what you gotta do. So you gotta say 180. So the way I got this beta minus alpha up here is because I said 180 minus, and then I open a parentheses, and inside the parentheses I had alpha plus 180 minus beta. Then I distribute the minus, collect like terms, and you end up with beta minus alpha. And that's convenient because now I have this angle, beta minus alpha, and I have the length opposite this angle, d. So the law of sines is good in that sense. The law of sines requires that you have an angle and the side length opposite. Okay, now I also I figured out this angle in blue. That one is just 90 minus beta because this is beta, this is 90, and they're supposed to add up to 180, so this should be 90 minus beta. I also figured out this bigger red angle over here. That one's 90 minus alpha. But turns out that this blue angle and this red angle, I did not need them. But I mean, I figured them out nonetheless just because I was like, well, might as well. I mean, the more tools I have, maybe the more things I can manipulate. Another thing that was not given to me, but I ended up needing, was this length that I'm calling h. So look at this line right here. This line, if you think about it, this line right now is there's a right triangle. There's a right triangle beta, 90 degrees, and blue angle up here. That's a right triangle. And for that right triangle, h is the hypotenuse. That's why I'm calling it h. And one thing I did is I solved for h. How do I get a hold of h? Well, that's what I have right here in red. I said sine of beta should be equal to opposite over hypotenuse. Sine of beta is x over h. And then I solve for h. So I multiply by h and then divide it by sine of beta. So I have an expression for h. I have this little expression for h. Or I know this side length now. And that's good now, because now look, now I'm going to just focus on the left angle, the angle that's alpha, 180 minus beta, and beta minus alpha. I'm just focusing on that triangle. It looks like this. Okay, and now what I can say is that sine of beta minus alpha, sine of beta minus alpha divided by length d should be equal to sine of alpha divided by length h. That's what the law of sine says. Except that I now know an expression for h. We figured it out up here. We said that h was just x over sine of beta. Alright, so I'm just going to kind of replace an h with that. So sine of beta minus alpha over d equals sine of alpha over h. But instead of calling it h, now I'm going to say x divided by sine of beta. Okay, so then what I have is sine up here. So I have to do, it's going to become sine times the reciprocal of this fraction, because we're dividing by fractions. So then that just becomes sine of alpha times the reciprocal of this bottom fraction. Well, that's sine of beta over x. And then I just multiply that out. So sine of alpha times sine of beta over x, because here the denominator is a 1, and whenever you multiply fractions, you don't need a common denominator. So just numerator times numerator, denominator times denominator. So I end up with this. And then what I did is now it's a matter of solving for x. So what I did here is I multiplied both sides by x. And then I multiplied by the reciprocal of sine of beta minus alpha over d on both sides. So d over sine of beta minus alpha. And then I multiply that out. And I guess this is the answer. This is my expression for x in terms of d, alpha, and beta. So I hope that this little explanation of this problem hopefully clarifies things. It's not as bad as it looks, but it definitely requires a little bit of attention. Okay, thank you. If you have any other such problems, let's maybe start thinking about making a list, and we'll post them on D2L and see if we can answer them.